Yeah, students, in continuation to the previous class, I'm going to talk about the architecture. Just now I have explained the von Neumann architecture and the Harvard architecture, and the von Neumann architecture is with the 8086 microprocessor and the 8085 microprocessor, whereas the 8051 microcontroller is having the architecture is called Harvard architecture. In the Harvard architecture, we know that the data transfer and the instructions fetching will be done in simultaneously, because there are two different buses are there for the data and as well as the instruction fetching, so that simultaneously these two works can be done by the 8051 due to the Harvard architecture. And this is the architecture of 8051, that is a microcontroller, controller on a computer on a chip, microcomputer on a chip. Then this is we will be knowing that microcontroller is nothing but it is a CPU along with the memory, some interrupts, timers and input output devices, all were integrated onto a single chip, that is called microcontroller. It is also named as microcomputer, and it is also named and it is a system on a chip or computer on a chip. So that these are the two interrupts and external interrupts, interrupt 0 and interrupt 1, and based on the interrupt control block, one particular interrupt signal will be served at once and it will be given to the processor, that is nothing but microprocessor, and it is a CPU, and based on the crystal oscillator, and it is oscillator which is a crystal oscillator, the oscillation frequency will be decided by these two capacitors, and these two capacitor and the crystal oscillator will generate the required amount of frequency for this processor, that is about the 11 to 12 megahertz. And we know that along with the CPU it will have the interrupts and the memory also. Memory, we know that the memory, on chip memory in features of 8051 we have discussed, that is the on chip memory. If that is about the read-only memory, that is code memory or the program memory, it is about 4 kilobytes, and whereas the RAM memory or the data memory, that is on-chip memory, is about 120 bytes of RAM, and it is it can be externally it can be compatible with the 60 more bytes, so that the total RAM memory, total code memory or the total program memory for the 8051 is about the 64 bytes, 64 kilobytes, and the total data memory or the total data memory on chip and off chip is about, here this is about 128 bytes, and the off chip also one more 128 will be there, so that the maximum data memory is about 260 bytes of memory it is having, and it is having the two timers, timer 1 and timer 0. This will count the data transfer, the amount of data has been transferred between the peripheral devices will be counted by the timers, and it is having the bus control. And we know that any system can have the three buses, address bus, data bus and the control bus, and all these three can be called as system bus, and that will be controlled by these control pins. And we know that the 8051 is an integrated circuit which is with the 40 pin IC, and in which the 40 pins and 32 pins serves as a IO ports that can be programmed bidirectional input output pins that can be accessed as input and output pins. And these IO ports are divided into four groups: port 0 group, port 1 group, port 2 group and port 3 group, and all these four ports will be with the 32 pins. Out of 40 pins, 32 pins will be programmed for the input output ports that are bidirectional ones, so that this arrow is indicating the bidirectional ones, and these can be address or the data. Whenever this is programmed for fetching the instructions from the memory, this can access the output port, and whenever it is reading the data, whenever it is accepting the data to the from the memory, it can be accessed output port. Likewise, these IO ports can be accessed as an input output port. And coming to the serial port, and it is having, and serial port is used for the serial communication between the input output device, between the peripherals which are interfaced with the 8051 to the 8051, so that here we are having the transmitter data, transmitting data, and the receiving data. Transmitter and receiver we will be having, and these are used for the transferring data between the peripherals and the 8051, so that whenever it is taking the data from the peripheral devices, its arrow is towards the serial port, and when it is giving the data to the peripheral devices, that arrow head is away from the serial port, so that it is allowing the two types of communication, that is transmission and the receiver. And this is having the 40-pin integrated circuit. We know that 8051 is having the 40-pin integrated circuit, and in which the 40 pins, 32 pins serves as the input output port. See this one, P002 to P07, these 8 pins acts as a port to 0. This is P0. That means next one is about P10 to P17. This is 8 more pins will be served for the port 1 group, and next one is a P20 to P27. This is one more group, that is P2 group, and the P3 group is there here, P30 to P37, so that all these 32 pins can be served as a input output ports. And we know that 8051 is having the 16-bit of address and the 8-bit of data, so that you can have the AD0 to AD0 to AD15 we can have. This is AD0 to AD15. Based on the program, these same pins can be used for the address, carrying the information of address, or the carrying the information of data. These 32 pins completed, and coming to the rest of the pins, we can call it as a bus control pins, and we are having, this is the transmitting data, and this is receiving data. We are having receiving we are having, this is about this transmitting data and the receiving data, and these two pins are here. This is transmitting data and the receiving data, both are the active high pins only, and it is having the two interrupts, that is interrupt 0 and interrupt 1. These two are the next two pins, interrupt 1 and interrupt 2, interrupt 0 and interrupt 1, and it is having the two timers, and here this is two timers, timer 0 and timer 1 is there. And coming to the, these are used for the read and write operation, and between the peripherals and the 8051, so that that indicates by these two pins. And this external clock, these are external applied clock signal, so that these are defined by the two capacitors, and here we are having the two capacitor here. This will be external 1 and this is external 2, so that it is a external clock frequency to generate the 12 megahertz of frequency. This is ground, and here this we are having this VCC is going to given by the 5 volts, and here this address latch enable, and whenever this address latch enable is high, then a lower byte of memory will be selected. Lower byte means that is having the 16-bit of address, that is B0 to 16-bit of address, that is A0 to A15, in which the lower byte of address, that is A0 to A7 will be selected whenever this address latch enable is 1. Otherwise that will be selected as whenever it will be active low, that will be selected the programming, that is external memory will be selected. And here also this is a programmable enable, and this is all the negatives will be connected. This is here based on all these things we are going to have the one particular pin configuration. See this one, this is address latch enable or program. Whenever this pin is high, it latches, that is address latch enable, it latches the lower byte. Lower byte is nothing but A0 to A7 of the address during the access to the external memory. Whenever the 8051 is accessed with the external memory, whenever address latch enable bit is 1, so that it is accessing the external memory. This pin is low during the EPROM programming. That means what, external programmable read-only memory is interfaced or accessing with the 8051, so that it will indicate the active low signal. And it is program store enable. Program store enable is the read strobe to the external program memory, which indicates the status of the program memory. This is about this pin is an active low pin connected to the ground. It is VPP, and which is nothing but it is a program code stored in the external memory and connected to the VCC. It is accessing the program code in the on-chip memory. That means what? We know that on-chip memory of the 8051, on-chip memory of the 8051, that is about the read-only memory is about 4 kilobytes, and it is 4 kilobyte in total of 64 kilobyte. And from that, whenever the 8051 is fetching the instruction from the code memory, that is 4 kilobyte, and this will be indicated by EA, that is VPP, EA or VPP, and this pin is active low pin. This is active low pin enabling the on-chip memory, and it is active low pin to the ground when the microcontroller is accessing the program code stored in the external memory, and it is connected to the VCC when it is accessing the program code in the on-chip memory. And next one is RST. RST is nothing but reset, which terminates the current operations, and applying high pulse on this pin, the microcontroller will reset and terminate all the activities. Next one is a port to 0 to port to 3. These port 0 to port 3 means these are 4 ports, port groups actually. Port 0 will be consisting of the 8 pins, 8 input output pins. Port 1 will be consisting of the 2 input output port. Port 3 will also consisting of the 8 input output port, and along with this we will be having, these are 8-bit bidirectional IO pins. We know that port 0 does not contain any internal pull-ups. Alternate functions of port 3 are this is we know that it is a receiver data and transmission data, interrupt 0, interrupt 1, timer 0, timer 1, read operation and the write operation. These are the external oscillations. These are external applied clock signal connected to the oscillator to generate the 12 or the 11 megahertz of frequency, and it is a power supply, and it is a ground, and all these things we have studied. All these things, these are the pin description for the 8051 microcontroller, and we know that the 8051 microcontroller is a programmable integrated circuit, and it is a microcontroller, and which is has been producing by the Atmel Corporation, and it reads the instruction from the code memory or the external memory, and such that based on that code, and it is going to execute the function. By executing those instructions at the program, it is going to control the devices which are interfaced to the 8051 microcontroller. And the memory organization, I will give the introduction to the memory organization. After that we are going to discuss the memory organization in detail in the coming class. Next one I am going with the memory organization. We know that on-chip memory of 8051, if it is a code memory, that is about 4 kilobyte, but is whenever it is interfaced with the external code memory, and that compatible with the total of 64 kilobyte of memory. And coming to the on-chip memory of 8051, if it is a RAM, that is random access memory, that is a data memory, and it is 128 bytes of memory it can have on chip, and that memory is a data bus, and that memory is a data bus, and it can be used for the special function registers, and that is 128, and to store the data. And the 8051 can be interfaced with externally one more 128 byte of memory. So the total 8051 can be compatible for the data memory is about 256 and 266 bytes of memory. If it is code memory, that is about 64 kilobyte of code memory that can have. So that code memory, external RAM size is about 128. On-chip memory, we will be having the on-chip memory, that is RAM and ROM. We will be having the internal RAM size is about 128. Special for that internal RAM will be used for the special function register. All these, see this one, this is a 8051 microcontroller. Assume that is having the internal RAM is used for the special function register SFRs, and internal code memory is also it is having, it is about 4 kilobyte. Actually if it is core 4 kilobyte, external RAM external code will be 60, so that total are 64. And if here internal RAM is about 128, we know that, and external RAM is also 128 memory, and these are the code memory, and it is having the 805. Code memory is nothing but it holds the program of the 8051. The total code memory is about 64 kilobyte. It is a combination of internal memory and external memory. On chip memory is about 4 kilobyte. Off chip memory is about 60 more kilobyte. To make it is 64 kilobyte. If on chip memory is about 4 kilobyte, and off chip memory will be the 60 more kilobytes. And both are internal and external. Here also, here external RAM is there. External RAM is also 128 kilobyte, 128 bytes, whereas internal RAM also 128 bytes. So the total RAM that can 8051 can have internally and externally is about 256 bytes for the data, and it is slow accessing speed, and it is limited to 64 kilobyte. And we discussed this one is up on chip memory. On chip memory, there are two on chip memories. We know that on chip memory is for code and as well as data. Now I am talking about the on chip memory for the data only. It refers to the memory that physically exists on the microcontroller itself only. There are two types, internal RAM and SPR, special function register, and the total combination of these two will be 256. Equal memory for the RAM and SPR is about 128. This is 128 and this is also 128. Total it is 256 megabyte of memory, and this is the memory organization of that 8051, that is 256 special function registers we have to discuss. And next one I am going to talk about the some of the applications of 8051. And we know that this is the applications of 8051. In automobiles we can make use the 8051 controller. In making the automation we will be using the microcontroller. In home appliances also we will be using. In rail transport, in signal communication, automatic giving the signals, we can make use the rail microcontrollers by setting the times. And industrial processing also we will be using, and remote sensing, robotics, and consumer electronics like microwave and all these things, we will be using the microcontrollers. And based on the microcontroller, that is 8051, we will be having the more applications. And in tomorrow's class I am going to discuss about the special function registers, which are nothing but internal RAM of a 8051. And thank you students, and thank you so much.